What's going on, guys? Welcome to the next video on C++. In this video we're going to discuss C++ fundamental data types. We're going to discuss the types, variables, and arithmetic. Alright, without further ado, we begin. Alright, so we're going to quickly revisit the assembly language, and we're going to see what is decimal, binary, and hexadecimal, base 16. I know you guys have a very good command on this basis, but just to revisit, if you guys don't know these things, I'm gonna explain again. So what's a decimal? Decimal is from 0 all the way to 15, so 0 0 0 1 2 3 all the way to 15. And binary, which is base 2, is either 0 or 1, and I'm going to discuss binary in the next few slides. And we're going to discuss also hex, in which I'm going to show you guys the hex inside this computer with this in the next video. But now we're going to see the binary, which is base 2, and it's 0 0 0 b is 0, 0 0 1 is b and 1, and 0 1 0 is 2, and you guys can see all the way to 15, which is 1 1 1 1b. So that's what the computer understands. Computers only understands binary, base 2, either 0 or 1. So you guys, as a C++ programmer, you guys must know these things because you're dealing directly with the hardware, and you got to manipulate the hardware, and you're going to see if there is an error coming from the computer, hardware, from the stack, or from anywhere else, you know. So anyway, we're going to see hex. Hex is base 16. Sometimes you see that a hexadecimal, because decimal is base 10 and hex is 6, so it's made up 16. It's from 0 all the way to 15, but the only problem is that it's not, I shouldn't say problem, it's as the 0, you can see that x 0x09 is 9, and it becomes 10 is A, 11 is B, 12 is C, 13 is D, 14 is E, and F, because the hex runs from 0 all the way to 15, which is F. So if you guys doing a programming and you guys see error, or the computer is giving you error, says 0 x 0 0, it means it's 0. Our 0 x 03, it means it's 3. Our 0 x 09 is 9, and 0x0a, it means it's 10. So there you go. And 0x0f is 15. Alright, we jump in another slide. Alright, the first things, because this video is about data types, C++ data types. Alright, in data types, we go to the basic, a bit, which we discussed in previous slide. A bit is either is a base 2, is either 0 or 1. So it's a box. 0 inside this box is either this bit is 0 or 1, or combination of both. So that's a bit, you know. So that's the main you can say the atom, the building block of computer. Whatever you see in the computer is bits, stream of bits. Is either, you can see why you looking at the computer as a video or multimedia, audio or photographs or voices, whatever you can see inside the computer is bits. Or as what's a nibble? Nibble is 4 of these bits, so it's 4 of these boxes. So a bit is 0 or 1, and nibble is 1 2 3 4, so it's 4 of these boxes is nibble. And what's a byte? You guys hear this word a lot of times, and I trust me, you guys will hear this like millions and millions and billions and billions of times, because this is the building block of computer. Everything inside computer is a bit, and nibble and byte, because we refer to 8 bits as a byte. So 8 bit is a byte. So 1 2 3 4 5 6 7 8. So 8 bit is a byte. You guys say is my 2 byte or 3 byte, 1 kilobyte, 2 kilobytes, or 1 gigabyte, so 1 terabyte. Whatever you say inside the memory, it's a byte. And so 1024 bytes is 1 kilobyte. and 1024 kilobytes is 1 megabyte. Back then when I started C++ in 1995, the biggest one we had is 1 megabyte, because I learned computer on 8-bit, then I moved to 16-bit and was very slow, and you could see all you could see is a dark screen, and I learned C++. But back then that was 1024 byte, 1 kilobyte was the medium we had, and 1024 kilobyte, 1 megabyte is the biggest we had. So if you could solve anything inside this 1 megabyte, you were the champion. And nowadays, as 1 terabyte is like normal $70 inside the stores, you could buy this type of memory because of the Moore's law. Whenever the time goes by, everything gets cheaper, all these transistors and all these bytes and memories. And 1024 megabytes is equal to 1 gigabyte. Even nowadays you see a small clip inside this 1024 pixel, you see nearly a gigabyte. 1.5 gigabyte is like a one movie. Alright, so 1024 megabytes is 1 gigabyte, and 1024 gigabytes is 1 terabyte. And you guys, if you go to the superstores nowadays, you can buy 1 terabyte for like $70. So that's how cheap it is. And 1024 terabyte is 1 petabyte. All right, so 1024 petabyte is 1 exabyte, and 1000 exabyte is equal to 1 zettabyte. So as you guys can see, all these started from the 1 bit, either 0 or 1, then it went to nibble, then it went to 1 byte. 1 byte is 8-bit, and there you go. After that you see all this byte all the way to zettabyte and yottabyte and nanobyte, which I'm not going to discuss in this video because zettabyte is a huge, you know, even exabyte, petabyte is huge. So 1 terabyte, I've got it, and you can fit like thousands and thousands and thousands and thousands of movies. I haven't done it yet, but I'm gonna try. So looks like it's a huge 1024 gigabytes, a lot. All right, we jump in another slide. I've just included a few noises and sounds in this slide so you guys don't fall asleep. Types, variables, and arithmetic. What is declaration? Declaration is a main thing in C++. A declaration is a statement that introduces a name into the program. So we declare something. It specifies type for the named entity. It tells the compiler about an identifier. The compiler must know what it means. Its type name, variable name, function name. If you guys remember in the previous videos, we discussed that the chef must declare the ingredients, must declare the potato, type of vegetable, or what type of any type of the vegetable or fruits or whatever the chef wants to put it in his or her dishes. So the chef must declare it. If you guys watch the cooking videos, you see that the chef always declares that I'm gonna put this much salt, I'm gonna put this much ginger, or potato, or gravy, whatever you call it. So I'm not a cook, but I know from the watching the movies, watching the videos, cooking videos. All right, so that's the declaration. And all C++ also requires that we declare the names, and the compiler wants to know. Compiler is like audience, wants to know what it means. Is type name, is it int, is it what, string, or is it char or car, our variable name, so our function, whatever. So we must declare. So declaration is that's the first thing to remember. And after declaration becomes a type, is defined as a set of values, a set of operation that can be applied to this value. We divide types into two categories. All right, so that's a type. What type is it? Is it int type, or is it floating type, data type? Inside the data type we have floating data types, or integer data types, or you name it, string data types, or enum data types, enum types. And object type is some memory that holds a value for some type, so that's object type. and a value type is a set of bits interpreted according to a type. That's the simplest. Variable is a named object. That's the simplest and very clear cut definition of the declaration: type, object type, value type, and variable. I didn't want to confuse you guys, go in lengthy that my data types and floating types and double type and string type or class type or function type. I just put it that the declaration, you guys will see these things all the time. You see the type, object type, value type, and variable. You see these things all the time because that's how C++ begins with. Alright, so we go back to the fundamental data types, and at the fundamental, because we're discussing the data types, just remember that we're discussing data types for Boolean values. So Boolean values is a true and false. What is bool? Bool is true or false. It's named after George Boole. He was a famous mathematician. His name was George Boole. He passed away a long time ago. But what happens at the Boole, the entire computer industry or the entire banking or entire any digital industry that is dealing with the datas are standing on these Boolean values, because it's telling the computer, is telling the systems that either is it true, which the computer is going to go ahead, or is it false, which is computer is not going to do anything. So you guys going to the supermarket and you scanning your card, the card quickly sends to the bank asking if this guy's got if he or she has got enough funds inside this transaction for the value of transaction, and the bank quickly sends either 0 or 1. So 0 is false, 1 is true. So the FPOS machine receives 1, it means it's okay, it goes ahead with the transaction. If it receives 0, it means it's not going to go ahead. Same thing applies with the programming. If you guys going there, so you logging in, and if your passwords and things correct, it quickly goes there and says if it's correct, and it sends 1, it means it's true, or sends false, it means it's not true. So that's a bool. Bool is very important. Bool is always ask questions. So there's a question mark. Is this correct? Is the computer says yes or no. Alright, so char values. Char is 8-bit is equal to 1 byte. So 1 byte of that we saw previous slide. So the 8-bit 1 byte is char. So that's how initially when Intel created the computer memory, that's how they put a char. Intel used to call this word. We're going to discuss that in few slides. So what is W char T? It's 16-bit 2 bytes. You guys don't see this W char because it's reserved for encoding for another languages. So UTF, if you guys heard, say you guys typing in Google and Google comes as UTF-8, it means is Unicode for that UTF-8. It translates for every language. There are many, I think it's 26 languages it translates, but we don't see this often. We don't see this because it's reserved for other guys to put this W char. I think T stands for translation at the end, and we go for short. After that, short is 2 byte. For integers, if you guys say doing small things that you only need 2 bytes, you go for short. So 2 bytes is 1 byte is 8-bit and another byte is 8-bit, so it's 16 bits. We don't see bit because it's a bit confusing. We only go to 2 bytes. 2 byte means 16-bit. So if one byte is 8-bit, it's 2 bytes 16-bit. And after that we go to integer is 4 byte. So just imagine if 1 byte is 8-bit, 2 is 16. If we're dealing with 32 bits. So int is 32 bits. And after that, if you guys still not satisfied with int, you can go to jump to long. Alright, so after that we're going for double data types and double floating point values. So the floating point is a float, which is 4 byte. So as I discussed the byte just before, and you guys can now imagine what is 4 byte looks like. And double is 8 byte. It means if you want big value, if you're working for a stock exchange or you're dealing with a very huge number, you're going for the bytes. And long doubles 10 bytes. So long doubles you don't need it unless you're doing the counting the atoms inside the universe. That's how you can fit all these numbers inside this. Or you're doing universal times, which from the beginning of the universe all the way now is 10 bytes. You can fit that number. I'm gonna discuss for you guys what's Unix time. So Unix times with 32-bit and a 64-bit. And I'm going to tell you guys that Unix time for 32 bits is going to expire in shortly, but Unix time with the 64 bit goes to 24 billion years. At the moment, it looks like we are at 14 billion, but that's irrelevant for this data types. I'm going to discuss in the next videos. Alright, so we discussed that the bool is either true or false, and is named after scientist George Boole, scientist mathematician George Boole, and the entire computer industry sits on it. Is it true or false? Sometimes true comes in the 1 and false comes in the as a 0. So 0 means false. Char, our car. Some people pronounce it as a char and some people pronounce it as a car. So car example is A, letters A, Z, 9, dollar, exclamation mark, digits 0 to 9, anything inside as long as it's 1 and is alright. So we go, next one is integer example. Integer example 1, 55, 100 and 2000. Any number is called integer. And double precision, double is double precision, floating point numbers. And what is the floating point numbers? As you can see that floating is 5.155, where you put this period or this dot here, double 5596 or 77. So if you guys going for counting currency and you is also counting dollars and cents, you're putting a floating point numbers. But if you don't want this, you can go for double, but double is a huge number. Alright, so we discussed that Intel, when I first learned computer programming, we used to study this, but not nowadays, but I'm gonna go through this. And when the first 8-bit computer came into existence, Intel used to put this char means car, 1 byte. So 8 bits is 1 byte. They used to call it byte, so 8 bits. Alright, so after that we go for 2 byte is short. And then when Intel went to 16-bit, they used to call these bits, word is 2 byte. So because they had more memory and they decided to go from car or byte to word. They used to call this word. And in the C, we used to call this short. On my left, it's a C and C++. What is called on the right, you see that Intel, because it's I took this from Intel's manual. And after that, when the 32-bit came into existence, the Intel used to call this double word. So the double word, the 2 byte, we used to store this int and long. So as you guys can see, the memory as the Intel progresses with this as 4-bit computer, then 8-bit, then 16-bit, then 32-bit, and now we see that 64 bits inside the market. I don't know when the 128 bits gonna come in, but at the moment we are stuck here with the 64-bit. So Intel used to call this double word. So double word is int or long. Alright, and after that, when the 32 bits came in, Intel decided to put this double long. We used to go in the quad word. Intel used to call this quad word. But the C and C++, we call this double or long, which is 8 byte. Now Intel bring in 64 bits computers, which is very fast and it's got a huge memory and RAM. I think some computers nowadays is the RAM is 8 gig, and the thing is like a 500, the hard drive. So that's a huge, huge. So now all this Intel they put it as a double quad board, our long double in C and C++. We call it C and C++ long double. All right, so that's the journey of the Intel's fundamental data types. So if you guys see byte in Intel, our word, our double word, our quad word, our double quad word, don't get confused, because in C++ on my left, on the left, I put it in C++. That's how we call it, and that's what it means. All right, so the range of values of data types. What's the range? So we discussed type and the size and the range of values in decimal. All right, so char is 1 byte, 8 bits. It goes to from -128 to +127, or 0 to 255. So that's how many digits you can store here, which is 128 to +127. Unsigned char. What's unsigned, assigned, and unsigned? As you guys notice, unsigned char is 1 byte. It's also char, our car is 1 byte, but it's non-negative. Unsigned one is non-negative. It goes from 0 to 255. Say your age. If you want to put person's age, the person's age never goes to negative. So the person's, you don't count the person from 0, like, oh, what is your age? Your age is -10. No, you don't count like that, because the person's age always plus. It goes to up. Or the tree's age, or the baby's age, or anything's age. But sometimes you want something for mathematical purposes. You want to go to, or scientific purposes, you want to go to minus, and in that case you use a signed char or signed int. That's how you use it. So that's the difference between signed and unsigned. And the next one, we goes to int. Int is 4 byte, and I think it goes to 2 billion, minus 2 billion 14748 3648 to 2 billion plus. So it's also, and unsigned int is also 4 byte. It goes to 0 to 65535. That's how the range of this int. And the short is, you guys can see that the short is lower than int, is 2 byte. It goes to minus 32768 to plus 326767. That's how many numbers you can, digits you can store. So 32,768 to 32,767 you can store. Unsigned one, as we discussed, that we don't go towards the negative, we always goes towards the positive, as a person's age. So the person age never goes to negative, it always goes to the positive. All right, so if you guys doing a programming, if you guys gonna go to work on a voting or registration, people's registration, our school, our college, and you guys given this program that you write this, the ID plus these person's age, people's age, you never goes to sign int, because people's ages never goes to negative, always goes to the positive. Plus IDs, all IDs starts from 1 all the way to million or billion, whatever. It never goes to the negative. All right, so long is 4 byte, and unsigned long is 0 to 42946967729. That's how many digits you can store. That's how many numbers. That's a huge number. Plus with the long also, we can go to 2 billion, from minus 2 billion to all the way to plus 2 billion. All right, so basic data types. So we discussed that the bool is a logical association using AND or true or false. That's a Boolean. Char used to store character codes in 1 byte, 8 bits. That's a char. And wchar is a wide character types, comprises 2 bytes, 16 bits, and is capable of storing Unicode characters, as we discussed before. Unicode is 16-bit code for approximately 35,000 characters in 25 languages. Yeah, so 35,000 characters in 25 languages. So you guys, if you go PHP or any other language, if you want to go to say translation, and if you guys want to store like Arabic or Persian or Urdu or Hindi or Chinese, you guys need this Unicode. It's called UTF. So there is a UTF-16, UTF-8, which I'm not going to discuss it with you guys now, but if you guys go to Google and type, and you guys immediately see on top bar it says UTF-8. It means Google is able to translate in many languages. UTF-8 is common for, say, if you want to do Russian or Persian or Arabic, you guys go for this UTF. Alright, integral types for short, int, and long, available for integers. This also refers to integral types. Alright, modifiers. C++ allows the char, int, and double data types to have modifier preceding to them. A modifier used to alter the meaning of the base type so it fits according to the needs. Alright, it includes signed, unsigned, long, and short. Alright, so we goes to arithmetic operator. So in arithmetic operator we have a plus. You can plus x and y's, our left values plus right value. Alright, so after that we have unary plus. Unary plus is a 2-bit and unary plus is 1. So you guys, if you guys need just a single plus, you know, so that's how you use. And we have a minus, x minus y, 2 values, 1 minus 2, or minus x. Say sometime you guys need just a single digit and you want to put it in minus 1 or minus 2. That's how you need a unary minus. Binary means 2, unary means 1, and multiply is x multiply y. What with multiply we don't have unary multiply. No, we don't have. We have unary plus or unary minus. So just remember that, because if you go to mathematics, sometimes you need a plus y, and you don't want to put a plus in front of plus y or plus x or plus a plus b, and sometimes you need a minus unary. That's C++ decided to put this unary. It means it's not a binary, it's not true. So we have a multiply, as you guys is very familiar with the multiply. We have division, which we divide. We have a remainder, of which we call it modulus for integer. It returns the remainder of integer division. It cannot be used on floating points or point values. Alright, so that's decrement. I'm going to discuss in a few videos, other videos, we're going to practice this arithmetic operators when you go discuss what is the size of this ints, floats, and other data types, what's the sizes, and what is this arithmetic operators. Alright, so we have decrement and we have increment. Alright, so comparison operators. So we discussed the data types, and what is comparison operators? Equal sign is not equal but assignment operator in programming. Just remember that it's very important. So if you guys given that what is a plus b, you guys don't put this is equal sign as front, because in C, C++, in all other programming language, this is assignment. We assign say your age, we put data type int, your name is equal to your age, because we assign your age to your name, to you. So that's assignment. Just remember that. That's not equal. When we're going to discuss what is equal inside, if you want to equal, what is equal inside this C++, C++, other programming languages. So as we discussed type, if your type is int, variable is equal to value. So the type is, say you want to put your age is int, plus your name or is a male female is equal to value, which is your age. So int is the type, you want to put it there as a 12 or 30 or 40, whatever your age is. So int example is int your name is equal to your age. Alright, so double equal is equal inside this programming. So double equal, you don't put a single equal. we put a double equal. So if you put a is equal to b, it means if you put a is equal to b, it means you're assigning b to a. You're not trying to say if it's equal. So not equal is exclamation sign plus is equal to. That's not equal. So equal is equal. This exclamation mark plus this one, it means it's not equal. So this exclamation mark is always not in the programming. Is less than, is x is less than y and x is greater than y. Less than equal to and greater than or equal to. So that's the comparison operator. So you guys never ever assume that this equal is equal, but it's assignment. So you're assigning a value to a variable. All right guys, that's it for this data types, C++ data type. In the next videos we go towards the programming side of C++. We're gonna see how many, we're gonna use the size of operator, which we see the size of data types, int, float, double, char, or any other data types. And then we go to comparison operators. Then we see everything inside this C++. I'll see you guys in the next video. Bye.